students. In the last class, you have learned about the operating system in detail, which was a type of a system software. Now, today you will learn about the remaining types of system softwares. Those are the device drivers, utility software, and the language processors. Let's start with the device drivers. Every device, be it a keyboard or a mouse or a printer, it needs a special kind of a software that will help to work in coordination with the computer. Without a device driver software, these devices such as the keyboard, mouse, etc. cannot work in coordination with the computer. That's why the manufacturer of a particular device also ships the device driver software along with the device. Those device driver software are available in the form of a CD. You can use that CD to install that device driver software into your computer system. Now, every time a device is attached to a computer, the operating system detects the device and then looks for its driver software in the library. If the driver software is found, the operating system installs it in your computer system, and once it gets installed, your device is ready to work in tandem with your system. For example, if you attach a keyboard device into your computer, the operating system will detect the keyboard device and then it will look for the associated driver software in the library. Now, if the associated driver software for the keyboard is found, the operating system will install it in your computer, and once it gets installed, your device, that is keyboard, is ready to work in tandem with your system. The next type of system software is the utility software. These are small but very useful softwares. Small in the sense they usually does not occupy much of a memory space once they are installed into your system. These utility softwares are basically used for performing various system maintenance, such as scanning of the hard disk, usually to fix some bugs or errors in the hard disk. Then comes system maintenance such as backing up of data and restoring of such backed up data. Some examples of utility softwares are this Defragmenter tool, resource monitor tool, and backup and restore utility. Let's come to the first utility software, which is the disk Defragmenter tool. Now, why do we need this disk Defragmenter tool? This tool is very much important. I will tell you the reason why. Now see, when the data gets stored in the hard disk, it is not stored in a proper way. That is, it gets scattered at random portions in the hard disk, due to which the time required to jump from one section of a data to another related portion becomes slower, which in turn reduces the speed of data access from the hard disk. So, just to eliminate that problem, the data stored in the hard disk should be aligned in a proper order, which can be done only with this Defragmenter tool. And once the data gets aligned in a proper order, the performance of data retrieval from the hard disk also improves. In this way, this Defragmenter tool eliminates the fragments from the hard disk and improves the performance while retrieving data from the hard disk. The next type of utility software is the Resource Monitor tool. This Resource Monitor window displays the real-time performance data of CPU, RAM, and other devices of the computer. Performance data can be with respect to the amount of memory utilized, or it can be related with the space consumed by a running application. And there are many key factors to it. This type of performance data is shown by the Resource Monitor window. The next type of utility software is the backup and restore utility. Now, why do you think we need this backup and restore utility? Now see, if we have confidential data in our system, sometimes it is desirable to take a backup of such confidential data for some security reasons, so that in case if the computer system malfunctions in the future, the backed up data can be restored again. Let's come to the next system software, which is the language processor. Now, every software, be it a system software or an application software, these softwares consist of some set of instructions that can be executed by the computer. And these set of instructions are written or developed using programming languages such as high-level programming languages or low-level programming languages. Examples of high-level programming languages are C and Java. Out of this C and Java, you will be learning Java in your class 11 standard. Whereas example for low-level languages are the assembly languages and the machine languages. Now, one thing you need to know is that a computer understands only machine language, which is a combination of zeros and ones. 0 or 1 are known as binary digits, and computer just understands machine language as a combination of zeros and ones. All other statements has to be finally converted to these binary codes. So all other statements written in a different programming language has to be finally translated into the machine language or the binary codes. This translation is done by a system software called as language processors. There are three types of language processors: assemblers, compilers, and interpreters. Now, before I explain you about these three language processors, that is assemblers, compilers, and interpreters, you need to know one thing, that in between the high-level language and machine language, there exists another language called as the assembly language. So assembly language falls in between the high-level language and the machine language. Now let's start with the first language processor, which is the assembler. Assembler is that language processor which converts an assembly level language code into the machine language. The next language processor is the compiler. Compiler is another language processor which translates a high-level language code into a low-level language, such as the assembly or the machine-level language code. The next language processor is the interpreter. Like a compiler, an interpreter too translates the code developed in high-level programming language to the object code, where object code can be either an assembly-level code or a machine code. But in contrast to the compiler, the interpreter reads and translates the code line by line and executes it. That means if a bug or an error is detected in line number 1, then line number 2 will never be interpreted until the error of line number 1 is fixed. And this is how an interpreter works.